Hey, good afternoon, everyone. So last Saturday we have started with the entity relationship diagram data model. So first we studied about like what is an entity. Okay, so that entity was anything in the real world is which have physical existence is known as an entity. Then we have studied also what are the types of attributes are there. So these are the like composite versus simple attributes, single valued versus multi-valued, stored versus derived attributes, null values, complex attributes. So all the descriptions I have just discussed in the last class. I think you can probably uh, you have to go through it. Okay. So this I'm just discussing about entity and types of entities where sorry types of attributes were discussed in the last class, and this was the naming conventions that for the ER diagram, that is a rectangle was used for entity, double rectangle for weak entity, diamond is used for relationship, then double diamond for identifying relationship. Then this is the attribute. If it's a simple attribute, then it is known it's a simple one. Then if it's a key attribute or the primary key, then we represent it by an underline. Multi-valued, we have two ovals. Composite comprises of multiple lines, and then the derived is dashed oval type. Okay, so we discuss about this one also. Is participation constants we'll study about today. So lastly, we saw this diagram. Okay, this conceptual diagram. We do this from this case study. We thought of this one entities, four entities were there: employee, department, project, and dependent. Okay, so these entities were drawn. So today we are going to study about the relationship. Yeah, let's see how many people have, only six people. Now, what is a relationship in entity diagram, ER diagram? Okay, so basically, relationship here you can see this diamond box, right? So it is adding, like relating these two entities here. Artist and song are two entities, two distinct entities, and we are joining this one. We are using this relationship. So a relationship basically means to relate two or more distinct entities with a specific meaning. Now this relationship, also you should always remember this relationship, you should use a verb for it. Suppose artist performs song, so it is a verb, right? Performs. So this is relating, this artist is related to song. How? Like artist performs song. Similarly, for the earlier diagram, if you go back, you can see employee works on project. Okay, you can just wait. Here, employee works on project. There can be a relationship. Here you can add a diamond and you can just relate to this. You can join this. Employee works on project. Then department has employee, or employee works for a department. Whatever you wish, right? Employee manages research department. That is also possible. This is the green part you see is the name of the relation. Okay, and that should be a verb. Now, what is the relationship type? So the relationship of the same type are grouped or typed into a relationship type. Now, for example, we have seen just right now the works on relationship type in which employee and project participate. So there is a relationship between the entity project and employee. So we can group them together by using the relationship works on. Right? These are two entities. Project and employee are two entities. So if we want to relate this one, if we can relate that using the relationship works on. Similarly, if we want to relate this department and employee, so we know that managers relationship is there where employees and department participate. Okay. Next, in ER diagram, I just told you diamond shaped box is used for relationship type. Okay. We use a diamond box for relationship, and how it is connected by a straight line we connect it. Okay, to two entities. Diamond is connected via the straight lines to the two entities. This is how we represent. Now, what is the degree of a relationship? Degree of a relationship means the number of participating entities in a relation. Number of participating entity in a relation. So minimum will be, obviously it can be binary or ternary. Let me give you an example. Here you see how many entities are participating. Two, right? Artist and song. And how can you know that it is an entity? You can just check the diagram. It's a rectangle. Rectangle means it is an entity, right? So there are two entities participating. Similarly, if there are three, then it will be ternary relationship. Okay, Ternary. And similarly, if there are more, it will be n-ary. Okay, it will be n-ary. Okay, if there are more than if the degree is more than 3, but generally we must try to avoid the ternary relationship. Okay, it's a general, like we cannot have ternary or higher relationship types. It's good that we follow always the binary only. Let me give you an example what is a ternary relationship looks like. Now you check here, instructor, semester and course are the three entities. Offer is a relationship, taught during is a relationship, course is a sorry not yeah, and can teach and offered during are the relationships. Now you see this offer relationship, how many participating entities are there? Instructor, semester and course. How you can check? Just check the lines, the straight lines where it is merging. You can find three, that is there are three participating a relationship is there. Okay, that is entities is there. So that means it is a ternary relationship, and we must try to avoid this kind of relationship. Also, now for taught during relationship, how many entities are there? Only two participating entities, instructor and semester. So that is why it is known as the binary. Similarly, for semester and course, how many participating like relationship is there, entities are there for offered during? It is two, right? Semester and course. Similarly, for can teach, it is two. So all are binary except one, which is the offers, which consists of three. That is why it is known as ternary. And we must try to avoid ternary and any higher types of relationship. Till this point, any confusion? Let me check.
No, ma'am.
No, right?
No, ma'am.
Okay. And always remember, when you draw this diagram, when you draw this ER diagram, please don't overlap everything. You just check the diagram, how like clean it is, right? It is not like there is this line is there. Here you draw the taught during relationship. You cannot overlap anything. Okay, it needs to be very much clear. You see, all the relationships are clear here. Okay. Next, what is a weak entity type? Sorry. Okay. Weak entity type, basically we know what is an entity. It is something which has physical existence. Okay, it's basically a part of the mini world which has physical existence. Okay, that means like we have a primary key for that, like a student or employee. Like we have an example of an employee. Let's go back. In employee, you check what was the you think it's the employee ID only. This is the since it's contained and underlined in the attribute, that means it is the unique ID or the primary key. You can this will be different for every employee. Okay, so this will be different. Okay, now if you check the dependent relationship, can you find any primary key? Can you find any primary key? Anyone? Yes, no? Just take the dependent attributes: relationship, birth date, sex, employee, dependent name. Is there any unique ID is there? No, right? Yes,
No, ma'am.
student? Yes. So when there is no unique ID is there, it is known as the weak entity. Okay. So this is not like identified by, and it is basically you need to identify it by relating to the strong entity. Like this dependent entity is related to the employee entity. Okay, we can find the unique ID for it. You can identify this weak entity by relating to the employee one for this case. And this weak entity will have a weak relationship also. Okay, employee that will have a weak relationship using a double diamond. We'll just see now. Okay, and now it will have always have a total participation. I know what it's meant. Now it will not be clear because we'll study next only what is total participation. And now from this weak entity type, we come across one more concept, which is strong entity. See, anything that for now, but before that we were aware of like entity. Entity has something which has physical like physical existence, and it has a primary key. Now we got a one more entity is the weak entity, okay, which does not have a primary key. Now, if you can define a strong entity type as like a normal entity which has primary key. Any entity which has primary key is known as a strong entity, and which do not have a primary key is known as a weak entity. Understood? Primary key is key attribute, like a unique identifying number. How do you identify it? Okay, just you'll be clear right now. I'll explain. Now, role names and recursive relationship. Now you see recursive relationship, you by in C also you studied about recursion means calling itself. So it is not always necessary that for uh, relationship you need two entities. That obviously you need two entities, but that two entities can be the same entity itself. Like we have in C programming self loop. Okay, so similarly here also we can have this concept of recursive relationship. For example, in the employee entity, one person can be a supervisor. Okay, one person who is a supervisor of all the employees, and other act as a supervisee. Okay, let me give you another good example. Suppose in our okay, let me take your class only. Okay, in your class, one person is a CR and other are just a student. So CR is whom we like communicate the information, and then CR manage, because and CR is also the representative of your class. Probably this won't be a good example of it. Okay, so role means that one person can have different roles to play. Suppose an employee, like we are an employee. Okay, we are an employee of an organization. We faculties are the employee of an organization. Uh, like we have Saurav sir, who is the coordinator of our program, right? I know your program. Saurav sir is the coordinator. Again, we are there working as a supervisor, but we are the part of the same department, right? These are the different roles. So, like project coordinator is a different role, faculty is a different role, right? Similarly, in any organization also, a manager is also an employee. Other department, IT department is also sorry, IT people are also employed. People working in the department are also employed. Okay, so there are two different roles in that case. Names are different. We are teachers. We are working as, because we teach you people. So we are teachers. Someone like Manas sir is there who do not teach. So he is the academic head is there. So these are the, but all are employee of an organization. We are all under INOTCHA, right? But we are teachers. Some are known as teachers, some are known as academic heads, some are known as program coordinators. So names are different, right? These are known as the role names. Okay, now we are all part of the same entity, that is the employee. Okay, just show you an example of the ER diagram. Check here. Employee one employee has the relationship supervision. It has 1:2, and what is 1:2, and you don't need to understand now, I'll explain you. Okay, these are the role names: supervisor and supervisee. Supervisor and supervisee. Okay, both supervisor and supervisee are employees only, but the role names are different. Are you clear?
Yes, ma'am.
Okay. Now, see, now this employee, these are the two. You can you see the participating entities? This is a relationship. Supervision is a relationship, and here the participating entities are employee only. In both cases, it is employee. So this kind of relationship is known as the recursive relationship. Okay, means you can think of it as a self loop. It does not have two entities, but yes, two entities are there, but it is relating to the same entity. Why people are joining so late? I don't know. Clear? This, forget about the other parts, forget about these things. I know you won't understand. Just take this one. Supervision, and this is a role name. When you use a self loop, always remember you need to mention the role names. So here in this side we have the supervisor, and this side we have the supervisee. Okay, and there is a relationship, okay, among itself. Clear? Now this employee works for department. Employee works for department. We are aware of this one. Entire entities. What were the entities? Like employee, department. Here it's like dependent is there, and then project is there. Okay. Now we know we can connect it. We have the supervision also. Then we have dependent. This is not complete diagram. Okay, it's like not clean. So and then this employee, it works for, don't think of this double line right now. You won't understand what is the double line or and one. This you won't understand. I know. I'll explain you. Just think when you go for this diagram, you draw employee works for department. Right. Single line only you can think. That is the relationship. You have just given the relationship name works for. Again, employee manages department. Department controls project, and employee works on project. Okay, this much only. Let's go back now. So this was done. Here I told you everything. Okay, now we should study what are the constraints or relationships. Constraints are basically what are the rules are there in a relationship. So there are two types of constraints are there. No, first is known as the cardinality, and and the second one is known as the participation. Now whatever we were saying, that one and then double line, we'll understand these two things. With these two things fall under this cardinality and participation only. So basically this relationship type, basically these are the constants on the relationship types. Okay, now let's check. First is the cardinality. So the cardinality ratio for a binary relationship specifies the maximum number of relationship instances that an entity can participate in. Now, what do you mean by the word instance? We have studied that instance means the original values. Now this employee is a table name. Right. Are you clear what is the employee? Employee is the table name or the schema, what you call. Inside that, it will consist like instances will be there, the original values. Like we have the John Smith, Tom Hanks. Like on that day lab class, you have entered the values, right? For you have created the table name student. Here the name of the table is employee. Okay, then we need to enter the values. So how many values will be there and how it will be related to the other tables? So it is mentioned that one only. So maximum number of relationship. Okay, now the possible cardinality ratio for binary relationship types are 1 to 1, 1 to many, and this one I'll explain you right now. Okay, you can just check for the relationship works for. Just let's go back. Works for department means n1. That means this this is the cardinality ratio 1:n, means works for n number of employees can work in a one department. That is why ultimately we have a relationship employee works for department, but we should remember that n number of employees works in a single department. Okay, now did you get this point? Suppose n number you have this BSc IT CTIS course where n number of students can enroll in this course. Okay, similarly n means many number. Okay, many people can work in a single department. That is why we have this n here and 1 here. This part clear? Yes, students?
Yes, ma'am.
Okay. Similarly, you check here, there is n:1 or 1:n, same thing. Okay, then we have employee managers department. See, now you have there two, this relationships are different, but the participating entities are same. Okay, how these managers are like 1:1? See, though like many people work in the same department, many people can work in the same department, there will be only one person that will manage the department, that is the head of the department. Okay, that is why one people will manage one department. Are you clear? Think of the real world situation.
Yes, ma'am.
Are you clear about these managers now? How like we have here one for work score, we have n:1 and here 1:1. Anyone not clear? Please, you can just tell me. Don't keep silent, please. Everyone needs to understand. Avinash, did you understand? Avinash, you there? Avinash, understood? Why 1:1?
Yes, ma'am.
Okay. What about Ankita? Ankita? What, Ankita is not there. Varsha? Yes, no, please write. At least you can write in the chat also. See, if you haven't understood, I can make you understand again. I can repeat 100 times, 1,000 times, but you need to understand. That's the thing. Okay? Last we have m:n. Now this, okay, Ankita left on me. Last we have the type, cardinality type is m:n. Now you can see what is the relationship type name. Employee works on a project. So n number of many employees can work on a single project. And if you go reverse also, like n projects can be, like many projects can be done by many employees, worked on by many employees. So that is why it is m:n. Let's go just check this one, m:n. So the relationship type works on it for cardinality ratio m:1 because the minimal rule is that an employee can work on several projects. Okay, now you check, a project can have several employees. That is why it is m:n. Clear? Yes.
Yes, ma'am.
You have to think two ways. Okay. Now, by going through it, we know that the cardinality is represented using these three letters, either 1, m, and n. Now let's go back. Now you have this, see, one employee, there can be, one supervisor, there can be n number of supervisee. Okay. Supervisor is someone, like there can be one teacher, like I'm teaching you for RDBMS, right? One teacher and number of students. Similarly, this is the one supervisor, another supervisor. For this class, probably now I am the supervisor and you people are my supervising. So that is why it is 1:n. Okay. Similarly, one department controls n number of projects. Okay, one department and like many projects can be controlled by a single department. If you go reverse also, it's the same thing, n:1. A single department can handle many projects. Many projects can be handled by a single department. Clear? You have to think in the real world basis. Yeah, I don't get any answer from the girls. Why? You don't understand? Where is the problem? Please tell me. See, this ER diagram is really, really important. Until and unless you practice, it won't be beneficial. Girls, we are in 2020, not in 1920, okay? So you need to buck up and just answer. Next, we can represent these diagrams. You see the managers, we have this kind of diagram. I think you have studied in class 12. Class 12, I think you people have studied the relations functions, right? Do you remember these diagrams?
Yes.
Yes, ma'am.
Right? So what does this mean? So it is 1:1 relationship. Check. 1:1. Entity is related to single department. So that is why. Then this is 1:n relationship. 1 is related, it can be related to many. So that is why it's 1:n. And finally many is to many. This kind of diagram, we are aware of it. And the next one is the type is participation constraint. Now I told you, right, the double line you have seen so far. Let me go back. This double line, this relationship double line, single line, because we have just studied in this class only, entities are related using a relationship using the diamond box, and we have straight lines connected to it. Now you can see straight lines, but you can see here there are two straight lines connected, and here is one single line. Why? So these are known as the participation constraints. Okay, so where we see the total participation constant, where we see the double lines, it means the total participation constant, meaning that every entity in the total set of one entity must be related to another entity. Okay, that means employee works for department. Now why this is total? Because every employee, okay, since he or she is an employee, every employee will work for a department, right? That is why we have total participation, because he or she is an employee, so he will work in a department. That is why total participation is there. Similarly, if a department is there, that means you need to check the reverse also. You go for this one, works for employee 1, so employee works for, there will be total participation. Now you check for this one, department. In every department all the employees need to work, right? So that is why total participation in this case. Okay, now what does this now partial participation mean? Partial means obviously some of the people will participate and some will not do work. So here you check employee manages department. Here does not include every employee. Every employee does not manage, they do not manage the department. Only a single employee will manage. That is why it is one employee will manage. Okay, sorry, this one employee, that is a single line, that's the total single participation. Okay, partial participation. But every department will be managed by employee. Okay, that is why we have total participation. Okay, you need to think, you need to question yourself and to find the answers. Similarly, every employee will work on a project, and on every project many employees will work, right? So that is why we have this total participation. And here also partial only, because we know this one, there will be a single supervisor only that does for the supervision relationship. So that is, it is known as the, everything is clearly written, so you can just go through it. Okay, basically this constant specifies the minimum number of relationship instances. Instances means participating entities, okay, that each entity can participate in. Okay, always mention everything. And we represent total participation by using double line, and by the partial participation by using single line. Now we know that entities have attributes. Okay, now the relationship types we studied can also have attributes. For example, this works, this one, managers have this, like from which date the manager started uh, to manage the department. Okay, so you can have a start date for this relationship here. Okay, you cannot have this start date here, because that start date means when did he join as an employee of the organization. Provide like someone may have joined their department as normal faculty. Later, after some years, he have joined as a head of the department. Okay, he has been promoted as a head of the department. In that case, that relationship, right, then head of the department will manage the department, your I not department, and then at which date it starts managing the department is the manages one. Okay, that is why it is the attribute for the relationship. Then employee works on department, it can have another attribute, like for how many hours the employee works on department, like how many hours a day that employee works on department. So this hours won't be here in the employee or in the project, it will be on the relationship type. So here we have written that even a relationship, it's possible for a relationship also to have an attribute. Okay, clear? So now when you refine
Yes,
the
ma'am.
entire diagram, and the final diagram will come out look like this one. Okay, think it's this entire diagram is for the ER diagram of the this one, the case study we have started the last class. I'll show you. After going this through this case study, the ER diagram, we finally come up with the all the adding effects. We come up with the this diagram, final diagram. Now I told you, when we have a weak relationship, a weak entity, that is we represented it using a this one double rectangle, and weak entity will always obviously have a weak relationship. So we using it, you represent it via using a this one double diamond, and it's related to which employee, the dependent is related to employees. Okay, and always please remember, ER diagram follow the top down approach. That means we will not will study from this one, like employee works for a department, employee manages the department, employee works for project, then employee has dependent like this with an employee supervision department. So this is how we start going through the diagram. These are the diagrams which will be used for your software engineering. Okay, the system designers, you have, if you gone through the SDLC phases, this diagrams diagrams you will have in the system design. Do you have the software engineering subject in this sem? Yes, students, you have software engineering subject.
No.
No,
All right.
ma'am.
Other batches have like BC and MAIS have. I don't know why. Actually, these are let me now give you a brief description. Okay. Basically, these designers, they're in the companies. There are different peoples are there, right? Someone go for coding, someone go for designing and everything. So these people, what they do is they design the system based on the client requirement. So these are the diagram they draw. One already flowchart you already aware of. One is this one, ER diagram. Now this ER diagram you cannot implement it. Okay, but you can have basically this ER diagram is a conceptual diagram. You need to have how do you represent the ER diagram using the relational model, that is the tables. These are the tables: employee, then department, project, dependent, and these are the attributes which you implemented already last class also you people did. And later we can we know how these tables are related. Okay, so that is all about the ER model. Any confusion? Any confusion?
Oh, ma'am.
I know like you people have to go through this one. It is tough. Okay, it is tough and very important concept. If you go through this gate questions also, it will be very tough. But I cannot like discuss the gate questions because we need some more concepts to discuss the gate questions now. I'll teach you like some joins and everything. Then only I can go for this gate questions. But till this point, ER diagram, any confusion? Are you clear about the cardinalities, constraints like cardinality and the participation and whatever the how we find the entities, at what are the attributes, types of attributes? See, I'll share with you the slides. Please go through it. Did I share the slide with you? Like this share was this slide. Did I share ER diagram? ER diagram. Did I share the slide? I forgot. I have to check them. Okay. Now, if you people don't have any confusion, let me tell you one thing. In the last class, we have a lab class, right? Last day, I was really very much disappointed. Like I've been repeatedly telling you, please try it on your own. Okay. Many of you have shown, like some, not many, like some of you have really worked hard and shown to me, but others haven't even tried to install the MySQL. If you don't install MySQL, there will be problem. But at least go for the DB fiddle part, right? And girls, I was really offended from you people because none of the people have shown me. No one even tried. So you don't want to learn the DBMS code. How will you pass the examination then? This is a very important subject, core paper, and is one of the easiest also. If you understand, you can score also and you can get your job. Many companies, all the companies, whether it's Facebook, Amazon, Flipkart, everyone is working on this database. But you do database MySQL, but people are now going for MySQL, NoSQL. But how will you understand NoSQL if you don't understand MySQL? So you have made up your mind that no, we are not going to learn. We are not going to install the software only. From next class, I don't know. You have to show me the program. By 4, everyone needs to show me the program. You need to install. You have days like today is only Friday. You people need to show me like every Wednesday. I'll give you some task, and by end of 4, you have at 4 o'clock you need to show me. No matter what. This way it's not going to work. You have to learn. All of you. You people need to submit the work like immediately. Probably we are not maintaining the lab copy, but you have to do your solve the problems. And obviously you need to jot the codes also, whatever you are writing, because for exam it is needed. So this time, like last time, if we are promoted, right? This time this may not be so. You may not be promoted. You never know. So please try out the programs. You need to learn DBMS. It's not that some other people will know that. See, if you have problem facing installation, today I'll share with you the link how to go for the installation. But still you need to do it. If you don't have laptop, for like go for phone, go for DB fiddle. I told you, like every option is available for you. Let me take the attendance for today then. Okay, thank you everyone. So we have a class tomorrow. I'll share the slide. Please go through it. Okay. Thank you, everyone.
Okay, ma'am. Thank you, ma'am.